All right, let's talk about why we use this. If we need to evaluate a trigonometric function, we can always use the reference angle and get the same value. From there, we just have to determine if it's positive or negative. So again, in class, you're going to learn some tricks. One of the tricks is going to be the ASTC trick, which means we have an acronym. We'll call it, in class, all students take calculus, you'll hear me say. And that's just a reminder of when something is positive or negative. Now here's how it works. If your angle is in the third quadrant, only tangent is positive. Tangent and its reciprocal cotangent, they would be positive. All other sine or cosine functions would be negative. If you're in the second quadrant, sine is positive, as well as CSC, its reciprocal. Everything else from tangent, cotangent is negative. Fourth quadrant, only cosine is positive. Everything else is negative. The first quadrant, all are positive. So all positive, sine positive, tangent positive, cosine positive. So that's how we're going to use this to simplify and get answers quicker. So here, remember how I said we can find the reference angles quickly? This reference angle, 4 pi over 3, the reference angle, and I'll call it a reference angle here, is pi over 3. So to get the value, it's sine of 4 pi over 3 will be really closely related to sine of pi over 3. Now for those who are not in class when they're watching this, you're not going to know the hand trick. But here if we use our hand trick, pi over 3 is our index finger. So you would bend your index finger, because remember the thumb is pi over 2. So if it goes down. So from pi over 2 to pi over 3, pi over 4, pi over 6, and 0. Those are your fingers. As you look at your hand, where you can see your palm, you would bend your left index finger, which would be pi over 3. You then flip your hand. Remember, it's psi y, cos x, tangent is y over x. Y is on top. When I bend, I have the square root of 3, or I have 3 fingers on top. That's the psi y. You always take the square root of fingers, so square root of 3 over, and since it's y, your hypotenuse is always 2. Whoops. I wrote h for hypotenuse. It would be square root of 3 over 2. Now we just have to figure out which quadrant is this in. This, again, if you weren't in class, this is going to be hard for you to follow, is plus 1. The plus 1, I didn't write that over here, is the third quadrant. These are the plus 1s. These are the minus 1s. These have no numerator, so it's blank. These are the times 2 minus 1s. That's what we do for the fourth quadrant. Here, what do I mean by plus 1s? If you go from the denominator up, you'll see that 3 gets added 1. These are the plus 1s. So this is in the third quadrant, which means tangent is positive. Sine would then end up being negative. So sine's negative. My answer here is not going to be square root of 3 over 2. My final answer would be negative square root of 3 over 2 because of the quadrant location. Now we could type that in the calculator and press enter, or I can just show you here that they're getting the same location, third quadrant. And you know what? I will type this in the calculator. I'm going to go over here. I'll type in sine, parentheses. The angle was, didn't work. Let me try that one more time. There it is, 4 pi over 3. And again, that's a radian there. That pi represents a radians. So let's type in that R button right there. Now when I press enter, I get this value. Now, is that the same thing as the square root of 3 divided by 2? Let's find out. Yes, it is. Well, other than the negative, we need to have that negative in there, which I did not include. I'm sorry. Negative square root of 3 to 2. And yes, we see that these are, in fact, the same exact answer. So we did do it correctly. So let's try this again. Tangent of 150. Well, 150 is in the second quadrant. This is easy because it's degrees. If it's the second quadrant, that means all students, this is in the student's quadrant. So sine is positive, which means tangent is going to be negative if only sine is positive. Let's check here. This is in the second quadrant, and I forgot to talk about how many degrees would make our reference triangle. Well, that would be 30. Again, the way we get there is, sorry, let me pull this out. How we got there is this way. You would start, and if this is 150 here, then you know you got it, then this is 180. All you would do is to find the reference angle is you would subtract. And that's how they get the 30. Is they would say 180 minus the 150, and that gives you your 30. So that's how they came up with that 30. Now 30, if you remember your 30-degree fan, you can look at your finger. That's your ring finger because it goes from degrees. It would be 30, 45, 60, 90, starting from the bottom, working up. I skipped 0 though. So we would take that ring finger, we'd bend it and flip it. Now remember, tangent is going to be the square root of top fingers, which is I have 1 finger, over the square root of 3 fingers. And we also know that it's going to be negative. So it'd be the negative of this. Now let's see if we can reduce. We could say this is negative 1 over square root of 3. And to not leave a square root in the denominator, you multiply top and bottom by that square root, which is in essence multiplying by 1. When I do that, I find out my final answer is negative square root of 3 divided by 3. That's my answer here. Let's check it in the calculator. So we think the answer is, we think we have tangent of 150 degrees. We think that's going to be equal to the negative, oops, think that it's going to be negative square root of 3 divided by 3. Press enter, and they are exactly a match, so that's correct. Finally, let's try this one. So what's the reference angle? This is in radians. It's simple. It's going to be pi over 4. This isn't in any of those rules because it's well over, so you'd have to think about it for a second, and I will just draw it. We have 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, because this would be times 2. Then we have 8 pi over 4 here. That would be a whole circle around is 2 pi, or 8 pi over 4. So if I take away 8 pi over 4, whoops, 15 pi over 4, and I take away 8 pi over 4, I'm left with 7 pi over 4. Now that's a times 2 minus 1, which is the 4th quadrant. So when I go back around here again, I'm going to come up with this angle here. That is 7 pi over 4. So it's in the 4th quadrant. Well, all students take calculus. Cosine's positive, and as it turns out, secant is a reciprocal, so secant is also positive. So we know our answer is going to be positive. So what is the cosine of pi over 4? Well, or secant rather, I'm going to use my hand trick. So pi over 4 is your middle finger. So you bend your middle finger and you flip it. Now, psi y cos x. So cosine of pi over 4, because that was our reference angle. Cosine of pi over 4 would be the bottom fingers. So we have 2 of them, so it'd be square root of 2. And cosine's always divided by 2. Now this wants to know the secant of it, which means flip it. It's reciprocal. So secant of pi over 4 would equal 2 over the square root of 2. Now we don't leave an answer in this form, so I'm going to multiply top and bottom by square root of 2. And that would leave me with 2 square root of 2 over 2. And we can actually simplify that by crossing those out. And so my answer is actually just going to be the square root of 2. Let's check it. Secant, 15 pi over 4. So come over here and type in SEC for secant. And I'll give him a fraction. 15. And then pi over 4. Now that pi is in radians, so I need to tell the calculator radians here. Press enter. I get that value. Now what do we think the answer is? We thought it was square root of 2. And it's a match, so we did it correctly. Here's their little image. And you'll see that, yep, it was located in the 4th quadrant. Again, all students take calculus. This is in the cosine quadrant. Since these are reciprocals, it also was positive. Now you try this one.